Section 8.4, Properties of Logarithms. This slide shows the properties of logarithms for any positive numbers m, n, and b, but b cannot be equal to 1. As we read through these properties and show a couple of examples, you will see essentially they are the properties of exponents. When I am multiplying like bases, I'm going to add the exponents. When I divide like bases, I'm going to subtract the exponents. And when I have a power given to a power, I'm going to multiply the exponents. So let's begin. Here I have log base b m times n, which essentially is log base b of m plus log base b of n. Again, when I multiply like bases, I'm going to add their exponents. So essentially this is the same rule, or called the product rule. Here's an example. If I have log 4 of 6xy, I can simplify this or break this apart into log 4 of 2 times 3 times x times y. Then, since these are all multiplying each other and we have a common base of 4, then I can rewrite this as log base 4 of 2 plus log base 4 of 3 plus log base 4 of x plus log base 4 of y. Of course, if we have an example like this and I expand it, at some point in time in this lesson, we're going to condense that back into this form of a logarithm. Let's proceed to the next property. Here I have the quotient rule. So if I have log base b, again common base, m divided by n, I can have log base b of m minus log base b of n. Let's see an example. Log base 2 of 2x over y. And we can also have combinations of these properties, as we'll see in this example. So I could rewrite this as log base 2 of 2 times x over y. And now I can rewrite this in expanded form of log base 2 of 2 plus log base 2 of x. That is the product rule. Now I'm going to use the quotient rule because I'm dividing by log base 2 of y, which is minus log base 2 of y. Finally, I have the power property, or power to a power. If I have log base b of m to the x power, I can rewrite this with this exponent in front of my log. So I can have an example that looks something like this. Log base 7 square root of 2x. Of course, I can rewrite my square root as an exponent. So I have the log of base 7 of 2x to the 1/2 power. Using my power property, I can write this as 1/2 log base 7 of 2 times x. Now I can go and use my product property, which is going to be 1/2 log base 7 of 2 plus 1/2 log base 7 of x. On these examples, you want to state the property or properties used to rewrite each expression. On the first one, I have the common log of 12 minus the common log of 4, and that should equal the log of 3. Well, let's see if we can get that to happen. I have a minus sign here. From our previous examples, I know that this is the common log of 12 divided by 4. And they are the same base because they're both common logs, which means they have a base of 10. Therefore, I can simplify this to be the common log of 3. And this is the quotient property. Next, I have 3 log of 5 of 2 plus 2 log base 5 of a half, and that should equal log base 5 of 2. So let's use the power property by rewriting this expression to be the log base 5, and this is 2 to the third, plus log base 5 equals 1/2 to the second. We can simplify these. This is going to be log base 5 of 8 plus log base 5 of 1/4. And that process was using the power property. Now, with the plus sign, I can use the product property, which would give me log base 5 of 8 times 1/4, which is going to give me log base 5 of 2. And we first use the power property, and then we use the product property. Here I have log base 3 of the 4th root of x cubed. I can rewrite the 4th root of x cubed with an exponent in fractional form, which is going to give me log base 3 of x to the 3/4. Now I can use the power property and make this 3/4 log base 3 of x, and that is by the power property. In these examples, I want to write each logarithmic expression as a single logarithm. Here I have the common log of 6 plus the common log of 5. Since I have the same basis, which is 10 for the common log, I can write this as a log of 6 times 5 because of the plus sign, which represents the product property. When I simplify, that's the common log of 30. Again, in this problem, I have common bases, so I can use the power property first, and that will give me the log base 7 of x squared minus log base 7 of y cubed. The minus sign represents a quotient, which gives me the log base 7 of x squared over y cubed. Following the same procedure, I have common logs on each one of these terms. Therefore, since they're the same base of 10, I can simplify. Using the power property, I'm going to have the common log of 4 cubed minus the common log of 2 to the 4th plus the common log of 1/4 squared. Simplifying each term, the common log of 4 cubed gives me the common log of 64 minus the common log of 2 to the 4th is 16 plus the common log of 1/4 squared is 1/16. Following order of operations, so I have minus and a plus from left to right. I'm going to use the quotient property first. That's going to give me the common log of 64 divided by 16 plus the common log of 1/16. Simplify, that's going to give me the common log of 4 times 1/16. And my solution is the common log of 1/4. On this problem, again, I have common logs through each term. Therefore, I have a common base of 10. Let's use the power property. That's going to give me the common log of 3 squared plus the common log of 2 cubed minus the common log of 4 squared. Again, simplifying each term gives me the common log of 9 plus the common log of 8 minus the common log of 16. Order of operations, working left to right, gives me the common log, since this is a plus sign, that's a product. That gives me 8 times 9, which is 72, minus the common log of 16. That's the quotient rule. That gives me the common log of 72 over 16. And I can simplify that to be the common log of 9/8. Again, we want to write each logarithmic expression as a single logarithm. Here I have log to the base k on each term. Therefore, I can simplify these. Now, we need to take a look at these terms because I can simplify this to be 3/5 log base k of x plus 2/3 log base k y minus 3/4 log base k of z. Now I can use the power property on each one of these terms, which will give me log base k of x to the 3/5 plus log base k of y to the 2/3 minus log base k of z to the 3/4. Then I can perform the product rule on these two. I'm going to go order of operations. So I'm going to go left to right. And that's going to give me log base k. And this is going to be the 5th root of x cubed times the cube root of y squared minus log base k of the 4th root of z cubed. This is now a quotient, so my final solution will be log base k of the 5th root of x cubed, the cube root of y squared over the 4th root of z cubed. On my next problem, I want to bring my 1/8 out, so this will be 1/8, and then I can perform this quotient, which will give me log of x over 5. And of course, we know that's the common log. And again, this is the common log, so I can simplify this to be 4/3 log of y. I can use the power rule here. This is going to give me the log of x over 5 to the 1/8 minus common log of y to the 4/3. Now I can use the quotient rule and get this under a single logarithm to be the 8th root of x over the 8th root of 5, and this is a division also, and that will be the cube root of y to the 4th. Again, I want to write each logarithmic expression as a single logarithm. Since these are all common bases, I can perform properties of logarithms. So I'm going to bring down my 1/3. Inside my quantity here is a plus sign, so I know that's the product rule. So that's log base b of 5y minus log base b, using the power rule, that gives me x to the 5th. This will give me log base b of 5y, using the power rule here, gives me 1/3 minus log base b of x to the fifth. And when I simplify under 1 log, that will give me the cube root of 5y over x to the fifth. On these examples, I want to expand each logarithm. Here I have log base 2 of x to the fifth times y cubed times z to the seventh. Since they're all multiplying, I can use the product rule. This is going to give me log base 2 of x to the fifth plus log base 2 of y cubed plus log base 2 of z to the seventh. Now, I can break these up further by using the power property, which is going to give me 5 log base 2 of x plus 3 log base 2 of y plus 7 log base 2 of z. Here I have log base 3 of the fourth root of x times y cubed over z squared. We first have to realize that this fourth root is covering the numerator and denominator, so we can take a better look at it by just simplifying it like this, where I have the fourth root of x y cubed over the fourth root of z squared. So I know I'm going to have a quotient here, but now I can simplify these logs by putting the exponents in fractional form for each one of my variables. So this is log base 3, and this will be x to the 1/4, y to the 3/4 over z to the 2/4. That will become log base 3 of x to the 1/4 plus log base 3 of y to the 3/4 minus log base 3 of z to the 2/4. Then using the power property gives me 1/4 log base 3 of x plus 3/4 log base 3 of y minus 2/4 log base 3 of z. Again, I want to expand each logarithm. Here I have log to the base k of 1 over z. I'm going to use the quotient property. That's going to give me log base k of 1 minus log base k of z. But if we recall, I'm not allowed to have b equal to 1. And that's because k to what power is equal to 1? Well, that power would be 0. Therefore, I'd have 0 minus log base k of z, which essentially is just a negative log base k of z. Here I'm going to use the product rule to begin with. So I'm going to have log 5 plus log of the quantity 4y minus 9 squared. Here I already have common log of 5 plus power property gives me 2 common log of the quantity of 4y minus 9. Again, I want to expand each logarithm. Here I have the common log of the quantity of x minus y to the 3/2 divided by z to the 4th, all to the 3rd power. Let's simplify the inside first. Log, I have x to the 3/2 times y to the 3/2 divided by z to the 4th, and that's all to the 3rd power. I know that the 3 can perform the power to the power operation, which means I'm going to multiply all the exponents by 3, which gives me the common log of x. 3 halves times 3 is going to give me 9 halves times y. 3 halves times 3 is 9 halves divided by z to the 12th. Now I can perform my product and quotient rule, which gives me the common log of x to the 9 halves plus the common log of y to the 9 halves minus the common log of z to the 12th. Now the power rule, which gives me 9 halves, common log of x, plus 9 halves, common log of y, minus 12, common log of z. My next one, I have log to base 3 of the square root of the entire quotient, and inside I have x times the square root of 5 and y to the 4th. Let's simplify these radicals into fractions. Log base 3 of, and I can begin in the numerator. I'm going to have the square root of x times the square root of the square root of 5. And on the denominator, I'm going to have the square root of y to the 4th. That gives me log base 3. Of course, the square root of x can be written as x to the 1/2 times 5. The square root of 5 in the interior is 1/2, but that's going to be raised to the 1/2 power because of the exterior square root. And on the denominator, that's going to give me the square root of y to the 4th is just y squared. Now I can use my product rules, which gives me log base 3 x to the 1/2 plus log base 3 of 5, and I can use power to the power here, which is 1/4, minus log base 3 of y squared. And then I can use the power rule, which is going to give me 1/2 log base 3 of x plus 1/4 log base 3 of 5 minus 2 log base 3 of y. On my last set of examples, I want to assume that the common log of 2 is equal to 0.3010, the common log of 3 is 0.4771, and the common log of 4 is 0.6021. Use the property of logarithms to evaluate each expression. Do not use a calculator. Here I have the common log of 9, but I don't have an approximation for the common log of 9, so I need to convert that. What I can do is make 9 equal to 3 squared, which is 9. So I have the common log of 3 squared. Now I use the power rule to have 2 common log of 3. I know the common log of 3 is approximately 0.4771, then multiply, and again an approximation to be 0.9542. Next I have the common log of 0.75, which I can rewrite as the common log of 3/4. Use the quotient rule and get the common log of 3 minus the common log of 4. Substitute in those approximations and subtract, and I get approximately a negative 0.125 for the common log of 0.75. Here I have the common log of the cube root of 2, which I can simplify to be the common log of 2 to the 1/3 power. Using the power property, I get 1/3 common log of 2. Substitute in the approximation for the common log of 2, and I multiply, and I get approximately 0.10033.